Hello Legacy students, Marsh here. So this video is the second day of factoring a quadratic equation. You're going to want that stacked foldable, maybe a calculator, and then pen or pencil, and then definitely those thinking caps once more. As I said, this is the second video. So in the first video, we talked about what does it mean to factor. We talked about greatest common factoring, and then we also talked about group factoring. This video is going to be on the last two tabs. So trinomial factoring and difference of perfect squares. So let's jump into trinomial factoring. So you're going to want to open up the tab that says trinomial factoring on the bottom. Now, trinomial factoring has three terms. Kind of like how grouping, factor by grouping, had four terms. So trinomial factoring only works when it's three terms because it's a trinomial, has three terms, right? Here's what you're going to do. You're going to write two sets of parentheses down. So that is these guys right here, this parenthesis. And then we're going to ask ourselves, what two factors multiply to make the first term? So is it x times x gives us x squared? Is it 3x times 2x gives me 6x squared? That is the first question we're going to ask ourselves. Then we're going to ask ourselves, what two factors multiply to make the last term? So if it's a 7, well, 7 times 1 will give us that, right? So factors, when I say the word factors, remember that's what multiplies to give it. What two factors, what two numbers are going to multiply? And then we're going to try different combinations until when you multiply, you receive the original problem. A lot of people will call this guess and check method because that's honestly what it is. You're guessing and checking until you find the right answer. So let's do a couple of examples here. And pause so you can get the other information before I start the actual examples. All right, so first thing, I'm going to write my two sets of parentheses, like that. And then what two factors multiply to make the first term? So at x squared, what two things make an x squared when I multiply? Well, an x and an x, right? X times x gives me x squared. Now I'm going to look, what two things make the last term when I multiply? So a 6. How can I make a 6? Well, a 3 and a 2, right? And a 6 and a 1. Now here's the thing. You want it so that when you put the numbers and you multiply the outsides and the insides, you need this guy to show up. Well, Well, I know a 6 and a 1 can make me a 7. And since there's no numbers in front of the x, I'll get a 1x and a 6x, which is 7 if they're both positive. So I'm going to make them both positive, and then I'll find that I can go back to my original problem. Let's try the second one here. So I need an x squared. So again, I'm going to write down my two parentheses. Well, how do you multiply to get x squared? Just an x and an x again, right? Now I need to make 16. How do I make 16? Well, a 4 and a 4, 16 and a 1, an 8 and a 2. I think that's it. Well, what if I put a 4 and a 4 here? Well, that would give me a 4x and a 4x, right? That's never going to give me a 6x, no matter how if those are both positive, both negative. So I know 4 and 4 is not right. 16 and 1 is just way too darn big. So I know it's got to be an 8 and a 2. So that's going to give me an 8x and a 2x. Now, somehow one of these, since this is a negative 16, that means either the 8's negative or the 2's negative, and the other guy's got to be positive. So I'm looking at this, and I need a negative 6x. So I'm going to look at my numbers, and I need to decide who needs to be negative for me to get a negative 6x? The 8, right? Because negative 8x plus 2x will give me a negative 6x. So then I could just fill out my signs right there. Let's try example 3. Oh no, this guy has something in front of the x squared. We haven't looked at that yet. Oh no, but it's 3x squared. Remember, it's just the same idea. How do you multiply to get yourself a 3x squared? Well, 3x and an x would multiply to give you that, right? Because 3x times x will give you a 3x squared. Now I got to think about this negative 2. Well, the only things are 2 and 1, right? So I'm going to put a 2 here. I'm going to put a 1 here. Now I'm going to multiply because I need to get a positive 1. So 3x times 2 is going to give me a 6x, and 1 times x is going to give me a 1x. Now looking at these two, in no combination can I get the 1x I was looking for. So that's a bad match. When that happens to me, I like to erase and I like to flop numbers around. So I'm going to put a 2 here and a 1 here and see if that helps me at all. So that was a bad match. 3x times 1 was 3x. 2x, or 2 times x is 2x. Well, that can give me a 1, right? If the 2x would be a negative and the 3x would be a positive. And notice this is a negative 2. That's why I know there have to be opposite signs. So I'm going to make a positive for what gave me the 3x and a negative that gave me the 2x. Let's try number 4 and 5 as well. So again, I'm going to write down a couple of parenthesis sets. Bring that all up for you guys. So again, what multiplies to give me the first term? Well, what makes 5x squared? Well, a 5x and an x, right? There's nothing else. How do I make 18? Ooh, 18, that's a big number. 9 and 2, 18 and 1, 6 and 3. Ooh. Okay. Let's put a 3 here and a 6 here. Let's see what that does. So 5x times 3 is a 15x. 6 times x is a 6x. Ooh, that is never going to make me a negative x. Gross. Not working. Okay, so 6 and 3, bad idea. A 2 and a 9. Let's do a 9 here and a 2 there. Oh, no. That would give me 45. That would be a bad idea. Let's flop the 9 and the 2, shall we? Let's put a 2 here and a 9 there. So 5x times 2 is a 10x. Ooh, a 9 times x is a 9x. I know 10x and 9x can make a negative 1x. That's by making the 10 negative and a 9x positive. So I'm going to make negative on the 2, positive on the 9. Whew. Marsh almost struggled there. All right. Ooh, gross. Look at these problems. Ugh. It's all right. It's all right. We got this, right? We got this. So, first of all, 87, I don't think divides by 3, but I wish it did because that would make my life a lot easier, but I don't think he does. So I'm going to check here with my calculator. Got to dig my calculator out. Forgot my calculator. Even though I told you guys to have a calculator, terrible. Ooh, everybody can divide by 3. So I'm going to actually factor out that 3 first. Plus, everyone has a y. Let's get rid of that y. So I'm going to factor out that 3y out of everybody. Make my life a little easier. So this will be a 10x squared. 87 divided by 3 is 29. So it'll be negative 29x plus a 10. That is a lot easier problem to solve. Now, this 3y, he's just going to come along for the ride. He's literally just going to be sitting in the front the entire time. So I'm going to put 3y down, and then I got my 2 parenthesis sets. Oh, how do you make 10x squared? Ooh, well, 10 and 1 and 5 and 2 with x's attached. Ooh, let's go 5x and 2x just because that seems a little friendlier. 10. How to make 10? 10 and 1 and 5 and 2. Now, I am only trying to get to 29. So see if I would do 10. You see it kind of be like 10 and 1. It might get a little bit gross, especially if it would multiply that 5. So I'm going to try 5 and 2. And I'm feeling really good about putting a 5 there and a 2 there. So 5x times 5 is going to give me 25x, and then 2 times 2x is 4x. That does, in fact, give me 29, but they both have to be negative to give me that negative 29. So I'm going to put a negative there. Now notice, this 3y, he's just hanging out for the ride. If you wouldn't have noticed that greatest common factor to start with, you would have had a much harder time figuring out the pattern. So always check for a greatest common factor. That should be your first step in any factoring problem. Now let's try the difference of perfect squares. Now this is only a 2-term factoring technique, and it is a pattern. That's all he is. Ultimately, first thing you need to identify is if you have each of the following. A, you have a difference. It's subtraction. Okay, so we're going to put that. It's a subtraction problem. That's the first thing you're looking for. 2, you're looking for perfect squares. 4, 9, 1, 16, 25. Those guys, all right? Or x squared. That's a perfect square. Then you're going to factor it into 2 factors, one positive and one negative. Let's try several examples. So first thing, x squared minus 49. Now notice, both of them are perfect squares and there is a subtraction in the middle. Here is how this works. Can you see or notice that this is technically a 0x in the middle? Okay, we can go back to our trinomial pattern that we've been noticing, in which we had 2 sets of parentheses. And then I asked myself, well, x times x makes x squared, right? And I need things to make 49, but add to 0. Well, that's a 7 and a 7 and 1 negative, 1 positive. Here's the thing. If you notice this pattern, aka there is a subtraction and both things are perfect squares, you can have this pattern every single time. Basically, it's the square root of the first term, square root of the second term, and a plus and a minus in the middle. So on this 4x squared minus 9, again, I'm going to put 2 parentheses sets out. Well, 4x squared, that's a 2x and a 2x. 9 would be a 3 and a 3. One's positive, one's negative. It's because I need that middle term to cancel. That's why both of the binomials have to be basically the same except a positive and a negative. Same thing here. Yes, it's been flipped, but the same idea. 81 would be a 9 and a 9. And then a w squared would be a positive w and a negative w. 16x squared minus 25, same idea. So 2 things, exactly the same thing that makes 16x squared. That would be a 4x and a 4x. And then a 25 is a 5 and a 5, positive, negative. 4x squared minus 7? Hold on. 7 isn't a perfect square. Right? Like, that's not, you can't multiply 2 numbers to get 7. This guy is unfactorable. Okay? So don't go on this whole rant of, oh yeah, it's 2 factors. That means I could do this cool little pattern. Be careful, because if the number is not a perfect square or not a negative, maybe it's a positive in the middle, you can't do it. You have to check both things. Is there subtraction, and are they perfect squares? Now, don't forget, we do need to use GCFs. So again, I'm going to look at these problems. Notice I have a 5 and a 20. I see a 5 can come out first. So I divide out both terms by 5. And I get x squared minus 4. That is 2 perfect squares with subtraction in the middle. So I can break that into its pattern of x plus 2 and x minus 2. Same thing here. They both have a 2 in there, definitely. And do you see how they both have an x to give out to undistribute? So if I did that, I would get an x squared minus 72 divided by 2. 36. Both perfect squares, subtraction in the middle. So I can factor further to x plus 6, x minus 6 for that problem. And that is the end of this video. I know it was quick, but factoring is something that we're going to continue to work on and get more practice on. Trust me, you will be factoring almost daily in class. So if you are struggling with factoring, please, please, please let me know and we can make up time to figure out when we can make it so that factoring becomes super awesome and easy for you. But until then, I will see you later, Sabers.